Integration by parts, here we go. The first thing I want to tell you about integration by parts, it is not a substitution method. This isn't like U substitution. With U substitution, you can do a change of bounds and find yourself in du land. But that's not what's happening with integration by parts. Integration by parts, you're just taking an integral and rewriting it a different way, but you're not changing variables. So if you've got to do integration by parts on a definite integral, an integral where you have an upper and a lower bound and you've got to plug it in, there's not going to be any change of bounds. Whatever the bounds are on the original integral, that'll be the same bounds on the final integral. I just want to make that clear to you. Okay? This is not substitution, you're just rewriting them. So integration by parts. Integration by parts answers the question, what if I have the integral of two functions, f of x times g of x? Well, we know I can't just take the antiderivative of f of x and the antiderivative of g of x and multiply them together, right? We know that's not true. I mean, I can give you something as simple as this, right? What's the antiderivative of x times x? Well, I mean, you'd think, well, can't I just take the antiderivative of that guy and the antiderivative of that guy and multiply them together? You know what I mean? Like, can't I just do that? And the answer is no way. I mean, because the antiderivative of x squared isn't 1/4 x to the fourth. The antiderivative of x squared is 1/3 x to the third. And like I told you the other day, I think you'd be hard-pressed to find two functions such that the integral of the product equaled the product of the integrals. That just never, ever happens. But we're still stuck, you know, having to figure out, how do I get the antiderivative of two functions that are multiplied together? Well, integration by parts answers that, or at least strives to answer that. So really, integration by parts is what we use for this scenario. You use it for the scenario where your integrand is two separate and distinct functions multiplied together. Okay, let me show you where it comes from. Where it comes from. And please do not write this down. It comes from the product rule. Imagine I had two functions, u and v, that are both functions of x. And suppose I wanted to take the derivative of uv with respect to x. Well, we know how product rule works. It'll be the derivative of the first guy times the second guy plus the first guy times the derivative of the second guy. Oops. Don't write this down, just watch and enjoy. You guys okay with that? Product rule. And now I'm going to do something a little tricky. I'm going to multiply both sides of the equation by dx. So all the dx's go away. So I have duv equals du times v plus u times dv. And then I'm going to take the antiderivative of both sides of this equation. The antiderivative of duv, the antiderivative of d anything, is just going to be what you had. But these guys I don't get to do anything with. I get v du plus the integral of u dv. And then I'm going to solve for the integral u dv. So I get the integral of u dv equals uv minus the integral of v du. And guess what? This is the integration by parts template. This is the thing you're going to have to memorize. That's the template you're going to use to rewrite integrals like this and make them doable. Let me give you an incredibly simple example. Example number one. Suppose I had the integral of x e to the x dx. I can't use u substitution because ordinarily I'd let my u be the exponent of an e to the x term. But if I let my x be u be x, that doesn't help me at all. Tell me, what could this exponent be such that I would be able to use u substitution? Instead of just e to the x, what could this be such that I would be able to use u substitution? What's that? Yeah, beautiful. Thank you, Zach. If this were 1/2 x squared, or even just x squared, right? If I had integral of x e to the x squared dx, well, now I could do u substitution. Let u be x squared. Du would be at 2x dx. I'd sprout a 2 here, and I'd go to town, right? I could do u substitution on this guy because the derivative of x squared is x dx, or 2x dx. But I don't have that option here, so I'm going to have to do integration by parts. And here's what you do. You set up your template. You go, okay, I need an integral of u dv, and that's going to end up equaling uv minus the integral of v du. So what you're going to have to do is choose your u and choose your dv. That is, one of these guys, you know, f of x times g of x, one of these guys gets to be the u, and the other guy, along with the dx, gets to be the dv. What determines your choice is you want to choose a u that, when you take the derivative of it, makes it a lot simpler, because, you know, you're going to have du here. You got u here, but it becomes du on the right side. And you want to choose a dv such that when you take the antiderivative of it, it doesn't get much more complicated. You see? Well, you've got two choices. Either your u is x or your u is e to the x. It's going to have to be one of those two guys, right? Because that's my f of x, g of x. So let's have a vote. Who here wants their u to be x? Okay, several of you. Why? Someone tell me, why would you want your u to be x? Yes?
Because the derivative of x is 1.
Yeah, and it doesn't get much easier than 1. I mean, you can't get much simpler than 1. Beautiful. Tell me, if I choose my dv to be e to the x, why is that a good thing? Because, you know, if I choose my dv to be e to the x, my v is going to have to be the antiderivative of it. Why is that a good thing? Yeah, because the derivative of e to the x is e to the x. I mean, it doesn't get much simpler than that. To take an antiderivative that doesn't even change the function, it doesn't get much simpler than that. You see? So here's what I would want you to do. I always do it like this. I go u equals x, and dv equals e to the x dx. I write it out like this, just like that. I write it out like that. And then right under it, I go, okay, I need to know what du and v are. So my du is going to be dx, and my v is going to be the integral of e to the x dx, which is e to the x. So I now have my du and my v. So I can rewrite this integral as uv. So I get x e to the x minus, and you notice I'm just following the template now, uv, there it is, minus integral of v du. I'm not substituting, I'm just rewriting it following that template. And now I have an integral I can take. I didn't know what integral of x e to the x is, but I know what the integral of e to the x is. It's e to the x. So I get my final answer, x e to the x minus e to the x plus c. And that's what the integral of x e to the x is. That's integration by parts. By the way, is there something I could do to this answer to verify that it is indeed the antiderivative of that guy?
Take the derivative.
Yeah, take the derivative. I'll do it right now. You know, hey, I'll take the derivative of this guy, x e to the x minus e to the x, plus c. Okay, I'm gonna do product rule, so I got the derivative of the first times the second plus the first times the derivative of the second minus the derivative of that guy plus 0. Does that work out? Do I get x e to the x as my answer?
Yeah.
Sure do. Yeah, cool. So, you guys ready to do it on your own?
Yeah.
I heard a yes. That's good enough for me. One yes, one single yes. Give this a try. Good luck, you guys. How are you going to do this? You got to choose your u, you got to choose your dv, get your du and your v, and then follow this template. I'll give you a minute. See how many of you are getting this. Yes?
Graduate.
What the heck? Thank you very much. Ramsey goes in the Ramsey row. Oh yeah, did I make it clear that I wanted both assignments, 50 and 52? Erase this so it doesn't fake you out. By now, I'm hoping everyone has chosen u to be x and dv to be sine x dx for precisely the same reasons why we made those similar choices on example 1. Let me walk around just to see what sort of progress people are making. Great. Yeah, now you can take the antiderivative of the negative cosine of x. Cool. Coolio. Yeah, beautiful. Oh wait, did you put a minus sign there? Oh yeah, you did. So it ends up being the integral of that positive cosine of x, isn't it? And by the way, good job. Yeah, looking good. Hey, you know? Right on, man. You guys are integrating by parts of the best of them. You know, this should be v du. So it should have been, where's your v? Oh, wait. If your dv is going to be sine x dx, then your v is negative cosine. Oh, is that you? Oh, your u's look like these to me. Because your name is Marsha, so everything's a v. Yeah, so you got uv, that's correct. You got an integral v du, and that's your v. That should be integral of negative cosine x dx. Yeah, good. All right. Yeah, beautiful. Keep going. Oh, by the way, your v is negative cosine. That should be negative cosine, not sine. Yeah, everything you're doing is perfect. Okay. You know, the integral of the cosine is the negative sine, not the cosine. Yeah. Yes, you would make no progress. You would only make things worse. Well, hey guys, I better get it on. Hey guys, I need to show you another type so that you can be enabled to do tonight's homework. So this guy, are you okay with my choice of u and dv and thus my choice of du and v?
Yeah.
Okay, then let's go ahead and write it out. I got negative x cosine x minus the integral of v negative cosine x and then du, which happens to be dx. Now, I gotta tell you, at this point, I urge you to simplify signs. Like I've got a negative negative, before I go any further, go ahead and call it positive. Don't be, or you'll end up like getting more and more negatives. The negatives will propagate, and then you'll be drowned in a sea of negatives. So go ahead and cancel negatives before you go any further, and then let's go for it. Yeah, so I got negative, so this ends up being a negative sine of x plus c. And there it is, that's the answer. That's what the integral of that guy is.
Why is it negative sine?
Because the derivative of the sine, whoa, I don't know. It's positive. Why was wait, what sort of insanity gripped me? Almost every kid I saw, their answer was negative sine.
Why?
It should be positive.
Yeah, it's positive.
It's positive sine.
I don't know, positive.
How many people got positive sine? Why am I so crazy? I was seeing negative signs and just nodding my head. God, oh well, stupid me. But anyway, always take the derivative and check your answer. Of course, when I took the derivative, I would have immediately found that I had the wrong answer. Okay, and by the way, now what if this were a definite integral? What if they said take the integral from 0 to pi over 2? Okay, you know what you would do? Just the whole time, just know that you're going from 0 to pi over 2. There's no substitution happening here, so there's no change of bounds. So you're just going to go from 0 to pi over 2 when you finally get done. And then finally you're done. You don't have a constant of integration now, because this is a definite integral from 0 to pi over 2. And then when you're finally totally done with your ridiculous integration by parts, go ahead and now we can plug in negative pi over 2 cosine pi over 2 plus sine pi over 2 minus negative 0 times cosine of 0 plus sine of 0. You see that? And so I end up with cosine, that's 0. I get 1. Hey, that was pretty cool. That was good. That was a good outcome. So the integral from 0 to pi over 2 of x sine x dx is 1.
I guess so.
Well, there you go. Okay, so if you get a chance to do definite integrals, just remember, don't plug in your bounds until the very end. Don't be thinking, oh, I got to plug in bounds somewhere in between. No. Just wait till you're totally done, then plug in your bounds. Okay, Eric asked me a question. What if we had flipped them? What if we chose wrong? What if we happen to choose u equal sine x, du equal cosine x, and so dv equals x dx and v equals 1/2 x squared, right? What if we chose wrong? Then you would get totally screwed up. You guys okay with that? Where my integral of x sine x would become 1/2 x squared sine x minus integral of 1/2 x squared v du cosine x dx. And the fact is, we're no closer to a correct answer than we were before. In fact, we're farther away from a correct answer. So I just want to let you know, if you choose wrong, you'll get messed up. This is still true. I mean, this guy is equal to that guy, but it hasn't helped you. You can't get a final answer because you can't get the antiderivative of that guy. Hey, there's one more integration by parts problem I need to show you, and then that's it. Then we're done. No, two more. Two more I have to show you. So this is going to be zippity-doo-dah. Here comes the first one. The integral of x to the third power log natural of x dx. You've got to choose a u and you've got to choose a dv. You've got to choose a u such that when you take the derivative it makes things easier, hopefully. And you've got to choose a dv such that when you take the antiderivative it doesn't make things very much more complicated. So what are you going to choose as your u and what are you going to choose as your dv here? And you've got two choices, right? X to the third and log natural of x. Those are the two functions being multiplied together. You guys ready to vote? How many people want their u to be x to the third? Okay, that would mean your dv is log natural of x. Do you know what the antiderivative of log natural of x is?
No.
Because I don't. Okay, how many people want their u to be log natural of x? Me too. Okay, so my dv is going to be x to the third dx, right? So my du is going to be 1 over x. Did that help things?
Yeah.
I think so. I don't know. I'd rather have a polynomial than a log natural. V is going to be 1/4 x to the 4th. Did that make things more complicated? No, a little bit, but not much.
Yeah.
At least I can find the antiderivative. I don't know what the antiderivative of the log natural of x is, so why would I even choose that as my dv?
Yeah.
And so now we have the integral of u dv equals uv minus integral of v du. And now we're just going to follow that template. I got uv, so I got 1/4 x to the 4th log natural of x minus the integral of v du, 1/4 x to the 4th times 1/x dx. Oh, I forgot the dx here. My bad. Was that a good choice? My choice of u and v?
Yeah.
Heck yeah. Because look at this. 1/x, this becomes 1/4 x to the 3rd dx. And then I can take the antiderivative of that. Minus 1/16 x to the 4th plus c. So I just want you to see that on tonight's homework, you're going to get a log natural in the integrand. And when that happens, let your u be that log natural. Okay, there's one more type of problem. Can I just, I'm just going to say one word about it. Let's say you had x squared cosine of x dx. Okay, you're going to choose your u to be x squared, just kind of like you did before. And then this is going to end up being uv minus the integral, and you're going to get an x sine x dx. And what would you do if you were left with that? Is anyone thinking do integration by parts again?
Yeah.
That's what you do. So you're going to get a problem tonight where this is like an x squared, and I just want to let you know you're going to do integration by parts twice. And we'll talk more about this tomorrow. You've got just a few problems. Good luck.